The reaction times for a hand-eye coordination test administered to 1,800 teenagers are normally distributed with a mean of 0.35 seconds and a standard deviation of 0.05 seconds. About how many teens had a reaction time between 0.25 and 0.45 seconds? So the data has already, or the question has already told us that the data is normally distributed. So you're going to draw a normal distribution curve with your mean in the center. And since how you have a standard deviation of 0.05, you know once you go one standard deviation in either direction, there's going to be a deviation of 0.05 from the mean. And so when we go to the right, 0.35 plus 0.05 gives us 0.4, which is one standard deviation. We add another 0.05, 0.45, which is two standard deviations away from the mean. And then add another 0.05, we get 0.5, which is three standard deviations from the mean. Going to the left, we subtract. So 0.35 minus 0.05 gives us 0.3, which is one standard deviation from the mean. Subtracting another 0.05 gives us 0.25, which is two standard deviations from the mean. And subtracting another 0.05 gives us 0.2, which is three standard deviations from the mean. Now, we want to know how many teens had a reaction time between 0.25 and 0.45 seconds. So looking at our normal distribution curve, here's 0.25 and then 0.45 seconds. Both of those values are two deviations from the mean, and we know based on the previous set of notes that the area up under the curve that is two standard deviations from the mean represents 95% of the data. So with that being said, we're going to take 1,800 and multiply by 95% to get the number of teens that had that reaction time. Now 95%, we know if we drop the percent, move the decimal two places to the left, is 0.95. So going to our calculator here, 1,800 times 0.95, wrong button, 1,710. So 1,710 students had a reaction time of 0.25 and 0.45 seconds. Part B, what is the probability that a teenager selected at random had a reaction time greater than 0.4 seconds? Now we're looking at the area under the curve because the percentages represent probability. And we want to know the probability that we select a student at random that has a reaction time greater than 0.4. So going to our distribution curve here, greater than 0.4. So we're going 0.4 to 0.5. You notice that your probabilities, we have 13.5, 2, and 0.5. We're going to add those together. 13.5% plus 2% plus 0.5%. Gives us 16%. Now we know if we use decimal form, that is also 0.16. The probability of selecting a teenager at random that has a reaction time greater than 0.4 is 16%.